properties for 2x2 eigenvalue. If the eigenvalues are distinct eigenvalues, like lambda is equal to 1 and 4 for 2x2 matrix, then eigenvalue is always 2 for 2x2 matrix. So it cannot be 3 or 4. Likewise for n cross n, we have n number of eigenvalues. If two eigenvalues are different, then for sure one distinct eigenvalue, there will be one distinct independent eigenvectors. Or we can write for every different eigenvalue, there will be one different eigenvector. Let us take example is from previous problem. Matrix B 3 2 1 2, which is a 2x2 matrix. We had lambda as 1 and lambda as 4, and now corresponding to lambda equals 1, we have eigenvector as -1 and 1, and corresponding to lambda equals 4, we have eigenvector as 2 and 1. Suppose if our eigenvalue is repeated, like lambda is equal to 1 1 or 2 2, or same eigenvalue or same eigenvalue, then the number of independent eigenvector are depending on free variables. let us take example from our previous problem. Let matrix be A and entries are 1, 1, 0 and 1, and our eigenvalue be 1 and 1, which are repeated eigenvalue. Then we will get only and only one eigenvector. So this is amount or number of eigenvector is 1 when a matrix is 2 cross 2 and we have eigenvalue as repeated eigenvalues, and when we have two free variable, then free variable which is nullity. When nullity is 2, then for a matrix, like we take a matrix 3 0 and 0 3, this is also from previous example, and we have eigenvalue as 3 and 3 which is repeated. Then we got x1 which is eigenvector as 1 0 and x2 eigenvector 2 is 0 and 1. We had two independent eigenvectors, as we have two free variables. So we can conclude number of free variables is equal to number of eigenvectors, and number of free variables is nothing but nullity. Next property, for any matrix, for our any matrix, maybe 2 cross 2, 3 cross 3 or 10 cross 10, first we have to check eigenvalues. Suppose our matrix is 3 cross 3 and all three eigenvalues are distinct or different for every different eigenvalue, there will be one different eigenvector, for sure. suppose if our eigenvalue are repeated or same, like we can take lambda equals 1 and 1, or lambda equals 3 and 3, etc. Then we have to check free variable. We have to calculate a minus lambda I, then rank of a minus lambda I. Free variable will be here free variable will be equal to total number of variables minus rank of a minus lambda I. Let us take two cases. Suppose our matrix is A, which is a 2x2 matrix, and we have two eigenvalues, and we have two eigenvalues. Then let us take case 1. And let us take lambda. Case 1, we will take lambda 1 and lambda 2, where lambda 1 is not equal to lambda 2, which means they are distinct or different. They are different, and lambda 1 and lambda 2 are distinct. Then corresponding to lambda 1, there will be one independent eigenvector, and corresponding to lambda 2, there will be one independent eigenvector. Like, or we can write like A is a 2x2 matrix. Where now corresponding to lambda 1, we will get a distinct eigenvector, and corresponding to lambda 2, we will get a distinct eigenvector. Now we take case 2. case 2, where lambda 1 is equal to lambda 2, or eigenvalue is equal to, or we have same eigenvalue like lambda, or we can take as lambda lambda, or lambda 1 is equal to lambda 2. In both the cases they are same. So we have two eigenvalues. Two eigenvalues are repeated. In this case we have one trick, which is total. This is our trick. Total number of variables minus rank of a minus lambda I. Finally we can say in 2x2 matrix we have two cases.